Okay, so the first question in exercise 4.2 is asking us to use the discriminant and determine the nature of the roots. So the discriminant is simply b square minus 4ac. We need to use this to determine the nature of the roots. What are the nature of the roots that we have? Real different roots when discriminant is bigger than 0. Real repeated roots means real and same roots when discriminant is exactly equal to 0. Non-real roots when discriminant is lesser than 0 means negative. So it's saying that use the discriminant, find the nature of the roots. If you find that the roots are real, only in that case proceed to find the roots, actually means find the solution if only the roots are real. If they are not real, then just do not bother finding the solution. That's no point finding it. So the first question, let's do it. It's x square minus 2 times x minus 5 equal to 0. If we take out the coefficients, we have the first leading coefficient a equal to 1, b equal to minus 2, and c equal to negative 5. We put them in the discriminant. Our discriminant is b square minus 4ac. This will give us the nature of the roots, that whether this equation will have real roots or non-real roots. If they are real, whether they would be repeated or they would be different. So we plug in all the values. B is negative 2, we square it, minus 4 times 1 times negative 5 because c is negative 5. So we get negative 2 squared is 4. Negative 4 times negative 5 is positive 20. So 20 plus 4 would be 24. Our discriminant value is 24. Think about it. It's a positive value. And when we have a positive discriminant, we have real roots and they are both different. They are not repeated. So we have two different real roots. The question said, if the roots are real, then find those roots. What are those roots? Calculate them. We have a number of ways calculating the roots. We can split the middle term, factorize the equation, equate them to 0, find the answers, or we can directly use the quadratic formula. In our previous class, we learned about the quadratic formula. We said if you need the value of x that turns the whole equation to 0, x is your root, x is your solution point, and that can be found by using the formula x equals to negative b plus minus square root of b squared minus 4 times a times c divided by 2a. You can see that b squared minus 4 times a times c is the discriminant. We already have calculated that value. So we plug in the values. We have negative times negative 2 plus minus square root of negative 2 squared minus 4 times 1 times negative 5 whole divided by 2 times 1. We simplify it. We already know the answer of this. Let me complete this square root sign so that it doesn't confuse you. This whole answer is 24. We have already calculated it, so no point going through this again. Negative times negative 2 is positive 2. So we have 2 plus minus square root of 24 divided by 2. If I split this square root, I have 24 can be written as 4 multiplied with 6. So the square root of 24 can be written as the square root of 4 multiplied with square root of 6. The square root of 4 is 2. So I have 2 plus minus 2 times the square root of 6 divided by 2. If we factor out 2, we will be left with 1 plus minus the square root of 6 divided by 2. This divides 2 and the whole multiplied 2 will balance each other. They will cancel each other. So I'll be left with two answers, which is x equals to 1 plus the square root of 6 and x equals to 1 minus the square root of 6. These are the roots. We have calculated these roots because the roots were real. The discriminant gave us the value that the roots are real. So we found these roots. Okay, otherwise we did not need to find. Look at the second part. It says 4x squared plus 4 times x plus 1 equal to 0. So if I write this equation here, we'll be just doing in a small portion. It's 4x squared plus 4x plus 1 equal to 0. My leading coefficient a is 4, b is 4, and c is 1. If we put them in the discriminant is b squared minus 4 times a times c. So this will be 4 squared minus 4 times 1. This is 16 minus 16 equal to 0. Right? So my discriminant is equal to 0. If discriminant is equal to 0, I will have two real roots, but they both would be same. So I will have real repeated roots. Again, they are real. The question said, okay, if the roots are real, then find the roots. We'll repeat the process. We use the same formula. We'll just change the values. Here B is 4, so I'll plug 4 in here. So B is 4, I'll plug 4 in here. A is 4, I'll put 4 here. C is 1, I'll put 1 here. A is 4, so I will put 4 here. In that way, I will have negative 4 plus minus, the discriminant is already 0. 4 squared is 16, 4 times 4 is 16, so this is 0. Divided by 2 times 4 is 8. So now my answers would look like minus 4 plus 0 and minus 0 makes no difference at all. So it would be minus 4 divided by 8, which is minus 1 upon 2. So both of my x values, x1 is minus half, x2 is also minus half. Both of the values are same as predicted. The discriminant said that discriminant is 0. That means two real values, but both of them are same. Okay. You look at the third equation. It says 3x squared equals to 8x plus 3. We will do the exact same process, and the discriminant will turn out to be a negative number. If it is negative, you don't need to find the roots. You will just skip it there. You would say, okay, there are no real roots. Then we look at the fourth part. See, the fourth part is a bit different. It is factorized, right? So if it is factorized, you can already sense that the roots are very easy to be found. First, x, okay, it's not equal to 0. I'm so sorry. So you need to convert it into a general form of the quadratic equation. You multiply x with 1, you multiply x with negative 3x. So you will get x minus 3x squared equals to 2. We make it a single side of the equation, so that would be negative 3x squared plus x minus 2 equal to 0. We got the value of a, the value of b, the value of c as our coefficients. We put them into the discriminant b square minus 4ac. We get the value either positive, negative, or 0. If it is positive, two real different roots. If it is negative, no real roots at all. If it is exactly equal to 0, we have two real same roots.